morning, everybody. We were discuss about the G16 elements. G16 elements, that is oxygen, sulfur, selenium, tellurium and polonium. All these are the G16 elements. In these elements, first element, that is oxygen can shows two allotropic forms. First is the dioxygen O2 and second one is the O3. What? Oxygen can shows two allotropic forms. First one is the dioxygen O2 and second one is the ozone O3. This dioxygen can shows first preparation methods of dioxygen can seen. First of all, preparation methods, then its physical properties of dioxygen, after that chemical properties of dioxygen, and lastly uses of dioxygen. All these terminologies of dioxygen can be seen, which is first preparation methods, then physical properties, chemical properties and uses of dioxygen, and lastly the oxides of dioxygen. What is oxides? The binary compounds of oxygen with metal or non-metal called as oxides. Oxides gives actually three types. First is the acidic oxide, second basic, and third one is the amphoteric, and last another one is the neutral oxides. All these terms can be discussed. So in this class we are going to learn what about the ozone. What about the ozone? It is next or second allotropous of oxygen. So see the what about the ozones? Ozone means to what? And its preparation methods. All these things. Ozone having molecular formula O3. This is ozone. It is allotropous of oxygen. Ozone is allotropous of oxygen. Ozone is allotropous of oxygen. This allotropous of oxygen can occur some distance from the earth, nearly about 30 to 32 kilometers from the earth. That ozone layer can be obtained. That is very important for the living beings. That ozone can absorb the UV rays coming from the suns. If that ultraviolet rays comes on the earth, then all living beings, that may be animals, can suffering from the skin diseases. So this ozone is very important. This is allotropous of oxygen. Oxygen in upper atmosphere. Oxygen in upper atmosphere is to what? Some distance. Atmosphere absorbs energy in the form of ultraviolet lights. What? From the earth on specific distance, the oxygen in upper atmosphere absorbs energy in the form of UV rays and changes into atomic oxygen which combines with that atomic oxygen combines with molecular oxygen to form ozone. What? How to form ozone? In specific distance from the earth, oxygen in upper atmosphere absorbs energy in the form of UV rays and changes into atomic oxygen. How? This is oxygen, O2. Oxygen in upper atmosphere, O2, can absorb UV light, and convert it into atomic oxygen. Oxygen can best produce the OO by absorb the UV light, convert it to atomic oxygen. That atomic oxygen can combines with molecular oxygen to form the ozone. What? In specific distance, the oxygen UV light absorbs to form the atomic oxygen. That atomic oxygen combines with oxygen to form the ozones. The layer of ozone protects Earth surface from harmful UV lights. The layer of ozone protect Earth surface from harmful UV rays, hence called as ozone umbrella. The layer which is present around the Earth surface, which protect the Earth from UV rays, is called as ozone umbrella. So this is a general of ozones. Then see the preparation method of ozone. How to prepare ozone? Preparation method of ozone. In laboratory, generally ozone is prepared in laboratory. In laboratory, it is prepared by passing. In laboratory, ozone is prepared by passing silent electrical discharge through what? In laboratory, the ozone is prepared by passing silent electrical discharge through pure and dry oxygen. In laboratory, we have to take oxygen, this oxygen which is pure and dry. From that oxygen, electrical discharge can pass. Then that oxygen is converted into ozone. In laboratory. First of all, take the dry and pure oxygen, and in which dry and pure oxygen, in which the electrical discharge can pass. Then oxygen is converted into the ozone. By this way, ozone is prepared in laboratory. So this is the preparation method of ozone. Then see the next, physical properties of ozones. Physical properties of ozone. Instead, the external appearance of ozone. in gaseous state, that ozone becomes pale blue in color. In gaseous state, pale blue color of ozone can occurs. But in next, that is liquid state, ozone can occurs dark blue in color. Whenever ozone is in gaseous state, then it becomes pale blue. But whenever in liquid state, liquid forms, then it is dark blue. While in solid state, it becomes violet. That ozone in solid state becomes violet black. So these colors can obtain depending upon their physical state. In gas, pale blue; in liquid, dark blue; but in solid, violet blacks. Second physical property, ozone has a characteristic smell. Ozone possesses a specific smell. It has some characteristic smell. Third, when ozone inhaled with breathings, when ozone is inhaled in concentration above 100 ppm, when ozone inhaled concentration above 100 ppm, then it causes headache and nausea. What? Whenever the ozone is inhaled, then it causes headache and nausea, but which having the concentration more than 100 ppm. Then last physical property, it is diametric in nature. It is diamagnetic in nature. So all these are the physical properties of ozone. First, its color depending upon physical state. Second, it has specific odor or smell. When ozone is inhaled having the concentration 100 ppm, more than it, then it causes the headache and nausea. And last one, it has the diamagnetic in nature. So these are the physical properties of ozone. Then see the structure of ozone. How to demonstrate structure of ozone? Structure of ozone. We know the ozone having the molecular formula O3. It indicates ozone containing 3 oxygen atoms can bonded with each others. Suppose first structure this O, second O, and third one O. All these oxygen can linked with first this double bond, this is single bond. This middle oxygen can possess a lone pair, one lone pair. Then it contains 2 lone pair, and third one is the 1, 2, 3, 4, 5, 6 is to 3 lone pairs depending upon the electronic configurations. Suppose this is first structure of ozone. Second one, this oxygen central, then second and third, it possesses the double bond. Then having the lone pair, only one lone pair, it possesses 2 lone pair, and it is third 3 lone pairs. lastly, finalize, it gives the simple structure of ozone. Likewise that actually this is simple structure of ozone. In ozone, 3 oxygen atoms can linked with each others, and we know the atomic number of oxygen is 8 and electronic configuration of that oxygen is 2,6. 2,6. In last cell of that oxygen containing 6 electrons. That is called as valence electron or outermost electron. Suppose this oxygen containing 6 electrons. Out of that, 1, 2, 3 electrons can form the bonding and remaining 1 lone pair is on it. This oxygen possesses 2 electrons, forms bonding and remaining in 2 lone pairs. This is 1 and 2nd. Likewise that the lone pairs can obtained on that oxygen atoms. So this is the structure of ozone. This is structure of ozone. It has angular structure, angular V-shaped structure. Ozone can possess V-shaped angular structure in which one central oxygen and another 2 oxygen can link with each other to form the V-shaped angular structure. In ozone, OO, 2 oxygen atoms, 2 OO bond lengths, 2 OO bond lengths is 2 oxygen atoms having the bond length is 128 picometer. What? This oxygen and this oxygen and with this oxygen having the bond length 128 picometer, another also 128 picometer. All these bonds in ozones are identical. So see the structure of ozone. First, it has angular V-shaped structure, V-shaped angular structure. Then in ozones, 2 OO bond length is identical, having 128 picometers. In ozone, OOO, all these bonds, OOO, bond angle is 117 degree. This oxygen linked with this, and lastly this bond angle in between them is 117 degree to form the V-shaped angular structure. It is resonance. What? It is resonance hybrid of ozone is resonance hybrid of 2. Ozone is resonance hybrid of 2 conical forms. This is the structure of ozone. First of all, V-shaped angular structure. Then OO bonds length is 128, identical. Then bond angle is 117 degree. And lastly, the resonance hybrid of 2 conical forms can obtain in ozone. Then see the uses of ozone. Uses of ozone. Which are the uses of ozone? Ozone is very important for animals which are lives on Earth. Why? Because ozone can protect all these living beings from the ultraviolet rays. So first use, it is used for purification of air. It is used in purification of air. Ozone is used in purification of air at crowded places such as cinema halls or railway stations, etc. or malls. Generally, in cinema halls, railway stations, malls, the crowd of people is high. At that times, the oxygen is less quantity. Then, the purifications of oxygen, ozone is required, or purification of air is used by that ozone. This is first use. Second use, ozone is used. It is used for sterilizing ozone is used for sterilizing drinking water. Ozone is used for sterilizing drinking water by oxidizing all germs and bacteria. First use of ozone is the purification of air in a crowded place. Second, it is used for sterilizing of drinking waters by oxidizing germs, small germs and bacteria, viruses. Third, it is used for bleaching. It is used for bleaching of oils, starch, etc. Oil, starch can be bleaching by using the ozones or silk. All these substances, oil, starch, silk, can be bleaching out by using the ozones. And last, it is used in manufacture of camphor. Ozone is used in manufacture of camphor. Then potassium permanganate. See again the uses of ozone. First, it is used in purification of air. Second, used in sterilizing of drinking water. Third, it is used for the bleaching of oil, starch. And last, it is used in manufacture of camphor and potassium permanganate. Okay. In next lecture, we are going to discuss about the chemical properties of ozone. Okay. Thank you.